So this is a project I made using an ESP32, an Arduino Micro, an LCD display, some buttons, a battery, a charger and boost module for the battery, and this GPIO header right here. It was originally, I guess, a box for a battery, but I just reused the box. It was a great size. It even has this part to it, which you just clip on your belt. Anyways, getting back to the project. So I'm going to cycle through some of the apps, I guess some programs that are on it, and briefly describe them. So this is an oscilloscope, I guess program or app or whatever you want to call it. This right here just takes the signal from here and outputs it onto the screen. I'll show you it working. So here's an example of a low amplitude sine wave being generated from this board right here. So as you can see, you can read it quite accurately. The only limitation here is the display, which after a certain while the resolution just isn't good enough to keep up. But yeah, so it can read sine waves, square waves, just like that. Anyways, going back to the unit. So here's a function generator. Oops. Here's function generator. It's not complete yet. It was complete before, but after porting it onto this, because I had to use a different library, I had to change everything and the colors kind of got messed up anyways. So let's say I set it to 9 Hertz. Now these aren't accurate. I do have to fix the timings, but pin 2 is connected to that LED right there, and you could see it's working. Anyways, so this is a reset button, which resets it. So if I go to the serial monitor, I need to, there's no demonstration. Anyways, pretty much you connect this to your phone, you can connect to the computer or any, let's say other microcontroller you're trying to test, and it'll show the serial data coming on the screen. Now most of these are not labeled because they're not permanent. There's a small Pong game I made. Yeah. So it has a scoring system, and yeah, not easy to play through a lens. This is actually a port manipulation, so I'm planning for this feature to be one of the more prominent ones, where you go around here. This right here has 40 little boxes, and each one is for one of these pins. Right now it just turns them on and off when you click this button right here, but I am planning for it to eventually be so that you could control all aspects of it. As you can see, it has like different protocols, different labels for each button. I'm planning to make it so that it can go through sequences, through instructions, just from here without having to upload it from the computer again. Right. I guess there's nothing on this page. Yeah. That's a small graphic. This one should be a few graphics. Yeah, this one it's just listing a readout from the analog in from the battery. Another picture being drawn. The purpose is, this one you can't really see, but there's one pixel moving around the screen really fast. Yeah, the purpose of that was just to test some graphics capabilities. This one's doing something. It's just not mapped onto the screen. I know because the back button wasn't working. Alright. Alright, we got something. So here's a small sorting algorithm I made. it draws a bunch of lines across the screen, each one with a random height. And then what it does is it compares them, the left and right lines, I guess. It compares them. Whichever one's larger goes to the right, whichever one's smaller goes to the left. And it just does this until the whole thing is organized, pretty much. So I'm gonna run it. It's drawn all the lines, and it organized them. This one right here is just to show that it has Wi-Fi, pretty much. So it just scans for Wi-Fi networks, tells you how strong they are and what channel they're operating. So it just constantly does that. If there is no network, it just says no networks found. And that's sort of like a frame rate test, I guess. So that is something I'm trying to work on, how to reduce that flicker. That's pretty noticeable. But otherwise, it's quite fluid. So that's it for the applications that are currently on the project. I'm planning to add a lot more in terms of that. As you noticed by now, it was plugged in the whole time. However, it does not need to be plugged in. It does have a battery in it, 1000 milliamp hours. So it gets around 2.5 hours of battery life when everything is turned on: Wi-Fi, Bluetooth, the screen's backlight, both microcontrollers. So that's decent. And when all that's turned off and the only thing turned on is the ESP32, it gets around 10 hours. And I'm assuming it should get a whole lot more in deep sleep mode. I did forget to mention that in the oscilloscope, this actually does change the speed of how fast it updates. So there's this second part of the project that's empty for now. This is the part that clips onto your belt. So what I'm planning for this to be is I want to put another microcontroller on here, which connects to this port when it's closed through I2C. They'll communicate. And all it's going to do is it's going to have buttons on the outside and a few LEDs for status. Let's say you set it so that when the room hits a certain temperature, one LED turns on, sort of like a notification. So when you press a button, it'll send data to here. This would probably be on deep sleep mode. It'll send data, awake you from deep sleep, and execute a certain program. Let's say you're doing network security and you want one hotkey to turn on the Wi-Fi, or to wake it up from deep sleep, turn on the Wi-Fi, set an access point so that when users connect to that access point, it prompts a captive portal and it logs the data. Afterwards, you can show whichever company or store you're testing, you can show them the vulnerabilities, and you could tell the consumers, you could explain to them their vulnerabilities and their awareness of that fact. That's just one example. You can have it mapped to turn on your lights, turn off your lights, your computer, your monitors. You can have it so that it controls a drone to do this or that, whatever it is. Now, space was one of the most limiting factors in this project. I wanted to add a lot more, like SD card support. I wanted to add some RF modules, but there just was not enough space. So I'm planning to have something about the size of this. It's a little box that I'll connect to the bottom of here. And it would pretty much be an expansion. So it would have, all most common, most useful frequencies in terms of RF, like 315, 433, 915. It would have SD card support. It could have GPS, accelerometers, gyroscopes, and all these components, these modules are very small. So in this size, many of them could fit in there. So all in all, I'm trying to make this as useful as possible, giving it the most use case scenarios, and hopefully this project turns out. I'm planning to modify this project for years to come. Hopefully this just becomes as good as I realistically can make it. This was plugged in for the entirety of the video, but it does not need to be. As I said before, there is a battery in here, so this is completely standalone, just like your smartphone pretty much. It's like a Walkman or like an MP3 player. Alright, so that's it for this project.